Welcome to this video on spring and work. I am Ravi Verma. I am the principal of Vedant Science Academy based in Katihar. This lesson is dedicated to Neil and Neil. I was talking to them about this topic and I realized that there are some aspects, there are a few things that can be very confusing when you discuss spring. So that's how this video came about, and I dedicate it to Neil and Neil. This is what we will cover, and this is a rather large video, so we will have it in 3 parts. The first part is introduction. So you saw that we will cover prerequisites, concept of positive and negative work, work and force, and potential energy. So the first part is introduction, and why do we study springs? In any subject, science or arts or history, when you're studying, you should ask yourself this question, that what is the benefit of studying that topic? So life without springs would be very uncomfortable. You see this train, and down below there are these springs. You see this motorcycle, it's called shock absorber. Here is that, and let me show you a train with spring in action. So we will look at this video. There's a train coming. And underneath you see several springs past, this one and this one, and now you're getting the view. So this is the view from under the bogie, and you see this spring is continuously going compressed and extended. So next time you're on a train and you feel the jerk, the impact, you should remind yourself that without springs, those jerks would have been far more painful. Let me show a video of a plane, of a motorcycle. So this, see, he's going on a very rough terrain. See all these rocks. So it is this spring which makes rider's life comfortable, so that every bump and every rock does not damage his back. You must have enjoyed a sofa set. Most likely underneath there are springs like these, which make sitting on a sofa a comfortable experience because they absorb impact. And most importantly, landing of a plane. So this is a view of a plane from under the carriage. Let me refresh this video. So this is, I just said, the view. This plane is about to land. And it's about to touch the runway. And now watch. It's about to touch. And let me mark certain areas so that you can focus on those. I want you to focus on this long shaft, and this, and this. All right. See what's happening. See how it is getting compressed. So it was like this, and then after the touchdown it goes in like this, the compression. Alright, so you see from here to getting compressed. So this is a remarkable sight. Alright, so how does spring do what it does, making our lives comfortable? So let me go to my blackboard, and there are two terms: momentum and impulse. Momentum and impulse. So when a plane of this size almost looks like a plane, okay, with one wheel here, two wheels, and then two wheels here at the back. So when this plane is coming downwards, the weight of this plane can be up to 80,000 kgs, and the speed, velocity, can be 90 meters per second. So the momentum is 80,000 multiplied with 90 kg meter per second. So this is 72, and then there will be 5 zeros. Kg meters per second. So impulse is rate in change in momentum and this is also the force. Alright, so from this 7,200,000 kg per meters per second, this has to go to 0. That means the plane has to stop at some point. So the force that the plane will experience will be this momentum divided by the time it takes to stop. So in this case, this can take up to 60 seconds. So let me put the numbers here. 72, 100, 1000 divided by 60. So this comes to 12 112 4 zeros. So this is the Newton. Now just imagine if the time of the impact was very brief, and by brief I mean 0.01 second. So the force in the second case will be 72, 100, 1000 divided by 0.01 Newton. So that means 72 there are two more zeros, Newton. So this force is amazingly high compared to this here. Let me draw a box around it. Now let me show you a video when the time of impact is very, very little. So this one is a plane crashing. So this plane crashed on a highway in California, and the plane looks like this after the crash. So the difference between this landing and this landing is the time of this impact. Instead of 60 seconds, 0.01 second. So spring, let me show you a graphical view. So spring, the normal length is this, and because of the impact of landing, it gets compressed by length delta L, and in this process time 60-second elapses. So this 60-second of preventing the plane from experiencing the full impact makes that difference. So springs give an object little time, and the time makes the difference in cushioning the impact. So all the examples we were seeing of how spring is used, whether it's a train or it's a motorcycle or sofa or landing of a plane, that it gives you little time before your momentum completely becomes zero. This is how springs work. You should study momentum and impulse to understand how springs help our life become more comfortable. So we saw how springs work, and now we go to part 2, which is the prerequisites.